Okay, so the Chapter 9 Rainbow Review continued. Alright, so rewrite each expression using the change of base theorem. So change of base theorem is basically you just use log 10 because it's the simplest one and you have a button on your calculator. So log base 5 of 8 is the same as log 8, which is just like log base 10 of 8, but honestly just call it log, divided by log 5. It's basically the bigger number over the smaller number when you're doing the logs. So this would be log of 36 divided by log of 2. Equations! Alright, so there's kind of different ways to do all these. Not all these. A few different techniques. So the best way to kind of look at it is think like, what could I do to it to make it look different? So for this one here, to make it look different, because this x plus 5 is kind of trapped in there, I can do exponential form. So I'm going to rewrite this as 3 to the power of 2 equals x plus 5. So 9 equals x plus 5. Subtract 5 from both sides. So x is 4. You could plug back in too if you wanted to and see if this makes a true statement. So log base 3 of 4 plus 5 equals 2. Is log base 3 of 9 2? It is, so we must be right. Let's see, this one here. 4 to the x equals 10. I'm going to take the log of both sides because x is in the exponent. I need to get it out of there. So log of 4 to the x equals log of 10. So x times log of 4, so I can move this over, equals log 10, which is 1, because 10 to the first power is 10. If I divide by log 4, x equals 1 over log of 4. I don't know what that is, but my calculator would if I wanted to find out. Okay. Switch colors. Let's do this one. These two are very much similar prospects, or processes rather. I'm really losing my words at this point in the game. Okay, so I need a common base. I can write 1/5 as 1 over 5 to the first, or 5 to the negative first. And then our power is x minus 2. I can write 25 as 5 squared, and then our power is x plus 3. If I simplify from there, 5, well, negative 1 times x is negative x. Negative 1 times negative 2 is 2. Equals 5 to the 2x plus 6. Since our base is the same, our exponents must be the same for it to be a true equation. So negative x plus 2 equals 2x plus 6. If we solve from there, and I add x to both sides, 2 equals 3x plus 6 minus 6. Negative 4 equals 3x divided by 3. So x equals negative 4 thirds. The last two are kind of combinations of the other methods. For this one, you would have to divide by 5 first, and then log both sides. For this one, you would divide by 7 first, and then use the process from this problem. Formulas with ln and e, natural log and e. Alright, big thing. ln of e is 1, e to the ln is 1. So ln e to the third, ln e is 1. It's just 3. This next one, I'm going to rewrite as natural log of e to the 1/3. ln e cancels, 1/3. This is another one you got to memorize. Natural log of 1 is 0. So now we can write as a single logarithm. The log rules are the same with natural log, but instead of seeing the word, or I guess, group of letters log, you just see ln. Otherwise the rules are the same. So I can rewrite this as 1/3 ln A plus 1/2 ln B plus ln C. So this is ln of A to the 1/3 plus ln B to the 1/2 plus ln of C. So I can multiply those when I'm condensing. So this is the natural log of A to the 1/3, B to the 1/2, C. Let's see. 3 natural log of x minus 2 natural log of y. I can move the 3 up and the 2 up. So this is natural log of x cubed minus natural log of y squared. We can condense with division, so we get natural log of x cubed over y squared. Expand each logarithm. This is using the properties the other way. So when I'm expanding, multiplication turns into addition. So this is natural log of p squared plus natural log of q plus natural log of r to the 4th. So I can move the 2, move the 4. So this is 2 ln of p plus ln of q plus 4 ln of r. Just picking a color. This is tricky stuff, you know, important decisions. All right, I'm going to do this one too. So first, division is subtraction when you expand. So natural log of y squared. Don't ask why I had parentheses over here with the ln of p squared. I'm not putting them here. There's no real reason. Natural log of y squared minus natural log of the square root of z. Natural log of y squared minus natural log. This is the same as z to the 1/2, and then I can move the powers. So 2 natural log of y minus 1/2 natural log of z. And then we have equations. Again, the biggest thing is just like, what can you do to these to make them look different? That's kind of the start, or to isolate the term with the x in it. So for this one, first I'm going to divide by 2. So then I have natural log of x equals 4. And then the x is stuck with the natural log, so I'm going to e both sides. E to the natural log, that goes away. So x equals e to the 4th. And again, e to the natural log goes away because it's 1. For this one here, 3x minus 1 is trapped in the exponent. I'm going to take the natural log of both sides because it cancels out the e. So I end up with 3x minus 1 equals natural log of 4. Add 1 to both sides. 3x equals natural log of 4 plus 1. Divide by 3. So x equals natural log of 4 plus 1, whatever that is, I don't know, I don't care. Calculator could tell me. Divided by 3. Okay. One looks similar. Keep in mind 1 over e to the 2x is the same as e to the negative 2x. So this is equal to 6. To be able to use this negative 2x, I'm going to take the natural log of both sides. So negative 2x equals natural log of 6. Divide by negative 2. X equals natural log of 6 divided by negative 2. The last one I'm going to do is this one here. Natural log of 4x minus 1. So this is trapped in there at the moment, so I'm going to e both sides. So I get 4x minus 1 equals e to the 1st, or just e. If you're using your calculator, you'd have to make it e to the 1st, but otherwise we can just leave it e. Add 1 to both sides. 4x equals e plus 1 divided by 4. So x is the lovely e plus 1 over 4. What is that? I mean, I can estimate, but to get exact, I would need my calculator. So we'll leave our answer just like that.